Those horizontal asymptotes are the ones that maybe are not there. But vertical, remember how we got them? We were like, what's going on? What makes an issue in the domain? Or a vertical asymptote. Remember, guys, for number 5, giving you a hint, because a couple people are stuck, okay? To find vertical asymptotes, okay? To find holes in the function, what are we looking for?
The one that's on the top and the bottom. Yeah. The one that makes 0 in the denominator.
Say that again, Kat, so everybody can hear
The
you.
one that makes 0 in the denominator.
The one that makes 0 in the denominator. The 1. What is the 1? Let's use better language. The x values that cause zeros in the denominator. That's an issue, right? We don't like it. Even the calculator goes error, right? So think about that. What x's cause the denominator to turn into a 0? Yes. You don't need to. Okay, can I use yours actually? I like that.
Do you have to sign your course cards today?
You weren't here yesterday. I did that on purpose. I wouldn't have to. By the way, don't forget to do that, okay? Course cards, all your teachers today, okay?
Is that right so far?
When did Mr.
Ish.
Oh no.
All right, let's start with one randomly selected student, right, from an Algebra 2 class, not this one. Not this one. Oh, maybe. Why don't we look at what the student has? I hope that's okay, right? That's what I hear.
It looks right to me.
All right, what do you think?
Yes.
Yes for what? Number 2 should be 3 units out.
Why don't we go in order? Can we? Yeah. Let's start with number 1.
Oh, that's what I meant.
Yeah.
You mean random student?
Random
She's
student. I mean,
not of
the person.
Let's start with number 1.
correct. Correct, I think.
Correct. Give me a quick explanation. Just why?
Okay, because I think
Sarai? Go for it.
The x plus 4, but 4 is the h, and since it's plus, the h has the rebellious teenager rule. The plus is a negative, and the negative is a moving to the left. So then it's a horizontal shift move for left.
4 units left. Thank you. Great explanation. Who agrees with Sarai? I love the agreement because she's absolutely right, that rebellious teenager. Talk about number 2.
Wait, isn't it 3 units up, not 2 units up?
Say that again.
Isn't it 3 units up?
Isn't it 3 units? Did you say right or up? Up. Isn't it 3 units up, says Hope.
Yes.
Yes, it should be 3 units up. Why?
Because there's a 3 at the end, which is k.
K is 3, right? Tell me about the 2 units right. But Mr. G, I see a minus.
Rebellious teenager.
Okay, wonderful. 3. Yes, we agree. Somebody justify that answer. Tatiana, shoot.
Okay, so it's -1 in the numerator, but you have to take out the negative because it has to be 1 in the numerator, so the negative means reflection across the x-axis.
Okay, what about the rest of it?
Oh, and if 3 plus 3 is h, and h is the rebellious teenager, so it's -3.
Okay.
So it goes to the left.
Good. Who agrees with Tatiana? I like it. I love my experts at transformations because this paper looks great aside from that K issue. Okay? This person, if this were a quiz 1 through 3, they'd almost get full credit, right? Probably take off a little bit for that 3 error. Okay? Now let's talk about number 5, right? Because that's where people were staring at the blank piece of paper. Amelia. Isn't the horizontal asymptote supposed to be y equals 0? Is her question. Why do you think so?
Because if the degree of p of x is less than the degree of q of x, ha is y equals 0.
Because of the degree of p of x, that's nicely read from notes, by the way. The degree of p of x is less than the degree of q of x. Horizontal asymptote at y equals 0. In your own words.
If the top one is, the degree of the top one is less than the degree of the bottom one, then it's 0.
Okay, the degree of the top one is
1.
1. The degree of the bottom one is 2. The degree of the top is indeed less than the bottom. And the rule is always HA at y equals 0, right? Which rule did this student use, though? Somebody else? Yeah. Sure.
First one.
Which rule did this student use? What's that one?
Oh, so.
What is the rule?
Oh. Okay. Oh.
Try it, try it.
Well, I had the first one, but she said it was the second one. Wasn't it the second one?
Well, when do we use this? Here's the question. When do we use that?
Oh, yeah, it's the second one. If the degree of P of X equals the degree of Q of X, the vertical
Horizontal asymptote.
the
That's it, yeah.
horizontal asymptote is at y equals 0.
In your own words, Tatiana.
So if the degree of the numerator and the denominator are the same, that's when you use what?
That's when you use the the a over b, right? So good. So we should make a correction here, okay? Correction being horizontal asymptote at y equals 0. Good. Okay. Blank is an issue. Anything that makes the denominator 0 is an issue. Do you agree with this student that -5 and -1 will cause issues, right? Absolutely correct. What about the student's domain?
Looks good.
Looks Gucci? Yeah, -5, -1, I agree. Okay, so now, this student claims that those are vertical asymptotes for sure. What could they have been? They could have been holes in the function, right? How do we know they are not holes, but they are vertical asymptotes? Yeah.
Okay, because in the numerator it doesn't like the numerator and the denominator have to be the same. So like on the top if it said x plus 1, then they'd be a whole.
So if the factor shows up at the top and the bottom, then it's what's called the removable discontinuity. I talked about this yesterday, which is a hole, okay? Are we missing anything? I don't think so, right? State the domain, we got it. What notation did the student use? Set notation, perfectly fine. Oh, we don't have the x-intercepts. We don't have the x-intercepts. How do we find that? Set what equal to 0?
Factors. Alright.
The factors equal to 0? Would you set f of x equal to 0? Asked Tatiana. What do you think?
Yes.
Indeed, right? And I did two. Yeah, can I take a picture? I'm gonna do it anyway.
It's wrong though.
What if it's wrong? Well, let's find out, shall we? You know? Okay, take a look at number 2. Tell me what you think. Tell me what you think. What did the student do first? Factor. It is always good practice, you know, with these. And next module, that's going to be really important, guys, okay? If you see a quadratic that's factorable, factor it, because there's probably a reason for that, okay? X plus 3x minus 1, x minus 3x minus 1. Vertical asymptote at x equals -3 and x equals 1. But then it says hole at x equals 1. Can it be both? It's one or the other, okay? Vertical asymptote or a hole. Is it a hole at x equals 1 or is it a vertical asymptote at x equals 1? It's a hole because it exists on the top as well, okay? horizontal asymptote at y equals 1. How'd the student get that? Did it shoot? What the random student randomly selected did in the do now, they followed the rule of A or B, right? Because the degrees are equal. Okay? Good. Am I missing anything from the directions here? Because I think there's a little more, right? So what does this mean? We're going to look at two different standards today that that are part of this unit. No notes. No, 8-2. There's only 2 lessons in this module. So it's a nice, short, and sweet module, okay? Well, it'll be a lot of 8-1, okay? But solving simple rational equations is going to be one of our standards. And that, like the baseball problem we just went over and the baseball problem I did yesterday, one of the things we have to do. And then graphing the functions like we did in the first part, identifying zeros, identifying asymptotes, all that fun stuff. So find a partner. I want you to work with this one first.
Thanks, Katie.
Graph first, okay? Work together.
Thank you.
And I'll go around and help you guys out. Sorry? Did I go past what? Oh, this one is basketball. Yeah. This one's actually basketball. I am happy to announce that you can use Desmos if you have it on your phone.
Describe them and give their describe them.
If so, describe.
Wait, for which one?
Yeah, like.
Yeah, I have that. Wait, so what did you do? Once, so I say y times. Yeah, but for that one, do you write I don't like that either. Okay, so yeah, so when you plug in -1, you get 1, -1.
Yeah. Wait, I got -1,
Yeah, it's 1 negative.
Yes.
Oh!
And they're just looking for the positive end. Because as x gets larger and larger, f of x is approaching infinity. The bottom. Okay, I want to use yours. I don't want to show pictures. Wouldn't it be approaching 0? Well, this is the first one I got, and I like how the student went ahead and used, what is this? End behavior, right? This is what the question is asking. What happens to f of x as this gets larger and larger? So they use end behavior, and it says it's approaching infinity. So I want to go back to the picture, if I may, of the graph. And tell me how it does or doesn't show that it's approaching infinity. Is that right?
It doesn't show that it's approaching infinity because for the f of x, since as you can see on the positive side, the right to the 2, as x gets larger than 2, it approaches the y, gets smaller and approaches 0, but it never touches it.
Okay, so here's this other student's answer to that question, and I want you to tell me what you think. Look at this student's number 4. F of x gets infinitely smaller. Okay, well, it's certainly opposite what the first student said. The first student said approaches infinity, which means get infinitely larger, right? This is not the case. This student says infinitely smaller. Better answer. Best answer? Best, not the best answer, right? What's the best answer for this? Yeah. Who wants to write it on my iPad? Because I don't want to do it. Here.
I'll write it.
Okay, that's cool.
She gets to use it.
Well, this is so much easier than I thought.
Yeah.
What did I messed up.
Why don't you use, would you use, here, you can erase with this guy. Okay. Why don't you use end behavior notation?
So,
As x, what is this saying? Approaches positive infinity. That's what this first part says. As x gets larger and larger. Or last part says. F of x is approaching 0. Will it ever touch 0? No, but we know 0 is kind of like our boundary, right? Or our limit. Another little hint at later, you know. Right? It's interesting. Good. All right. So number 1. And I'd like you to talk to me about the setup first. Talk to me about the setup first. Go ahead, Tatiana.
Okay, so do you want me to explain
What the setup was, yeah.
Okay, so they did how many games they won over how many they played, and they added n because they're trying to get to the goal of 75. So that's how many more they need, and then they equaled it to 0.75.
And why did they add n on both the top and the bottom?
Because every game you play, whether or not you play it. If you win a game. On the bottom.
Right. If you won the game, then you played the game, so you have to add it. Like if it was 2 more games, it'd be 20 out of 32, right? So because you have to add it to both. Okay. Good. Then what happened next? Someone else. The student did what? Emilio. Cross multiplied to solve algebraically. Is there a way for us to do this with technology? Probably, right? How could we use a graphing calculator to solve this, just to review? Plug it in how? What do I do with this side? Put it into y1, right? Can I do that? What do I do with that side? y2, and then what am I looking for? The intersection, right? So you can do this with a graphing calculator, okay? Good. Same thing happens in number 2. So let's talk about number 3.